All right, good afternoon, everyone. Welcome to the 1 o'clock session for Wednesday in the auditorium. This panel is titled, Where Are You Going and How Did You Get There? People Movement Visualizations. We are going to cover new visual analytic tools and methodologies for analyzing trajectory and path data obtained from connected vehicles and devices as they move throughout a transportation network. And I suspect this is a rather broad topic, so basically we're talking about transportation and how to visualize it. Our first speaker is Brendan Hogan. Yes, I did write my notes with a crayon. Brendan Hogan is a lead modeling and simulation engineer at MITRE's Center for Advanced Aviation System Development. He works in the areas of air traffic flow management and aviation safety in support of the Federal Aviation Administration. And if you were around yesterday in whatever that room was, the reception room, he was giving demos, so hopefully some of you got a hands-on look at some of the tools that he has built. So Brendan, thanks for joining us. The floor is yours.
Thank you, Michael. Good afternoon, everyone, and thank you for sticking around after lunch. I'm going to be talking about a map-based tool for analysis and visualization, particularly for events that evolve spatially. So why bother? Right? Obviously, if you have trajectory data, you can plot that data and get a sense of where things are. Although if you're particularly interested in the nature with which things are interacting in time and space, it can be tough to get a sense for that interaction from analysis alone. And further, if your audience for communicating this out at the end of the day consists of subject matters or domain experts that may not necessarily be analysts or engineers themselves, then your beautiful, if geeky, statistical graphics may not be as impactful of a method to communicate with those audiences. And so we've put together a tool that we think helps address some of these gaps. It's a web-based tool for analysts to bring their own data and help bring it to life. So let's consider a moment the role this plays in the life cycle of an analysis project. From the beginning, getting an orientation of a project's location and the type of event of interest, to doing the analysis itself, to communicating the story at the end of the day. Obviously, there's a role for visualization probably in each stage of this process, although the tool that I'm talking about today I feel like is most helpful at the beginning, getting a quick look at what's going on, and at the end, bringing together a clean, concise way to communicate the results. And that's where I'm going to, my talk is going to concentrate. So let's take a look. To give an orientation of what we are looking at here, there is a map overlay underlying this. It is intentionally subtle because I want to talk more about the things that are on top of the map. But just to get a sense of where we're at, we're looking at a section of the northeastern United States. You can see a border marks the Atlantic coast running left to right up in the corner here. Long Island is jutting out just east of New York City. Cape Cod in Massachusetts is up in the upper right corner. We in DC at the moment are sitting down around in this area. And aside from that, so, there's some controls at the top for importing data and choosing how you style it, choosing how to adjust the background layers and how bright or dark you would like it. Looking at this now, I wish I had it a little brighter at the moment. I'll also mention that you can feed this data of any type of trajectory data. So if you have a sort of a simulation model where you're evaluating some proposed concept that is not yet implemented, and you want to show, like, what would it look like if you did this? For that, literally, what's up here now is recorded real data from the evening of July 11th, earlier this year. There's a subset of flights either arriving or departing into one of the big three New York City airports, Newark, LaGuardia, or JFK. And with that, I'll hit go and let this evolve for a moment. This can make for a nice, relaxing, hypnotizing view but if you look closely, there's an orchestrated dance of arrival patterns and departure flow patterns that are taking place here. You can kind of see these traffic organized into lines exiting the region, entering the region. If you pay attention closely, you can see some flights appear to be heading in the wrong direction. I'll come back to that point in a moment. But it's useful to sort of just get a sense of what's going on. Let things evolve on the map and stare at it. You can pause and rewind and frame advance and really sort of get a sense of the problem at hand. Okay. Next, I'm going to add a little more context to the view here. So I've added instead of just showing the location of these aircraft at this moment in time, showing a brief tail behind the icons that represent the prior 5 minutes of trajectory history as of this point in the animation. Also added, it shows up better on your screen than mine, added a representation of the weather. You can see there's a significant storm system moving through the region that evening. If you were traveling that day, I expect it was a long day for you as a result of that. But again, otherwise, exact same animation that we just watched with a little more context added here. And a couple things jump out. The trajectory tails here help illustrate some of the patterns in the organization a bit more. You can see if you squint that some of the aircraft appear to be wiggling around more significant areas of the storm cells as they're passing. And it also helps to highlight some of this stuff up in this region where the aircraft are flying in circular holding patterns. So we've taken another step, added another layer to this replay. So I'll step back for a moment and think about what we have. We have trajectory data, and if you have, in addition to your sequence of positions, if you have a timestamp associated with those positions, we can replay that. If there's other attributes of interest, let's show that as well to complement the story. So suppose, for instance, that if some of your trajectory points, the entities involved are experiencing some delay, and I've indicated that in my crude sketch here as the red dots. And suppose the rest upstream and downstream of that, the entities are flowing freely. Okay? And obviously you need a data schema to drive all of this, but if you have that contextual information, let's put it together and complement the view here. So I'll go back to the same scenario that we just watched a moment ago, and note that I've added two things. One, aircraft icons are colored red if they're currently in a holding pattern as of this moment in the animation playback. Also in the lower right is a chart that shows the current number of aircraft out of this sample that's heading towards New York City, either Newark, LaGuardia, or JFK. How many of those flights are currently in holding at this moment in time? And we'll let this evolve for a moment. But suppose if the story that I'm trying to tell, I want you to get a sense of the nature of these holding patterns, where they're taking place, how flights are entering and exiting these holding patterns, and why, because of the weather. I can highlight that and make it pop by using some coloring to highlight the, that particular aspect of my trajectory data that I want to show. And further, it's nice to sometimes put a number on this as well and have a data-driven chart evolve that's speaking to the same thing as the entities that are moving across the map. And you might note that there was a time, say 15 minutes ago in simulated time, where there's as many as 13 aircraft heading to New York, all currently in holding patterns at that time. And I should add, as an aside, that not to be alarmed, these flights are all separated in altitude. Aircraft are instructed, though we're looking top down, and you don't get that from this view. I'll assure you it was safe. These aircraft are instructed to hold, say, you enter the holding pattern at 10,000, you enter at 12,000, et cetera. So, it's all above board, but it's still of interest to review this stuff. And I think we've seen over the course of the conference a number of nice dashboards where the metric of interest is presented in a data chart. And I want to elaborate on that a moment and say that this charting element here, there's nothing magic about the number of aircraft currently in a holding pattern. I just picked it for the purpose of illustration today. But I've exposed a tool for analysts to sort of build their own charts of their own metrics of interest. And I'll take a moment to show you what that looks like. All right, so the chart itself is a Plotly chart. If anyone's familiar with Plotly, they're doing some amazing work. Plotly also has a chart setup library that goes along with it. And that's a nice way to bundle up an ability to sort of facilitate the common task of taking your data and putting a chart on it. And all of the style aspects of this are available available, knobs and levers for the user to adjust. And if I had made this after the color workshop this morning, I probably would have done a better job, right? But I picked red. This is basically a line plot that I had selected to fill the axis below. That's this control here, fill down to y equals 0, but et cetera. All of these controls are available to the analyst to set up however they choose. Also, the particular type of chart and the variables that are plotted are at the user's discretion as well. So if it's more useful to your story to show a box and whisker plot or a simple scatter plot or whatnot, those are all options. Further, the nature of the dynamic relationship between the chart and the entities that are moving around on the map is configurable as well. When we watched the replay a moment ago, the chart showed the full history from when the scenario started up until the current animation time. But those are adjustable as well. And this snapshot here shows what it would look like if the user selected to instead filter just from the current time back to include 15 minutes of history, say, if it was useful to sort of pinpoint things in a smaller time window. And of course, you don't need to have your chart evolve over time, but it can be nice to help tell the story. Also, the chart element itself is a nice interactive thing. User can mouse over and get a data block on points of interest. You can click and drag to zoom in. So to summarize, I think I'd like to reflect on the versions of visualization that we just walked through. And I'd like to argue that layering complementary pieces of information and watching an event evolve over time, can be a really useful way to, as the theme of the conference would say, to get a better view of what's happening. And further, it's a really powerful thing to enable analysts to build their own displays, their own charts of the metrics that are relevant for their work. And so, collectively, we have put this tool together to help people bring their analysis to life and to make it pop. I want to, before I wrap up, give a nod to the fantastic open source community. We've been able to leverage a number of elements. And I'm also grateful that I've been able to give back through some pull requests to a couple of these projects as well along the way here. And with that, I will conclude. Thank you.
Anyone has any questions, would you come up to this mic to ask it? Does anyone have questions?
I was curious, is there a timeline or a speed type of element in the dashboard?
Yes, there is. Thank you. If we skip back a bit, say here, I forgot to call that out. I have a little clock here. If this was live, I could drag it around or click to expand it and speed it up or slow it down, or just zap directly to a time point that I know I want to look at. Thanks.
Anyone else? All right, well, thank you very much, Brendan.
All right. Yeah, thanks so much for your time.